Welcome back, Wolf Trap Math Club. Today we're going to talk about an interesting concept called parity. Now that sounds quite tricky, so let's write down the word. What does the word parity in mathematics mean? Well, parity is just a sort of a complicated way of saying whether a number or a bunch of numbers, whether that result is either even or odd. So whether a number or a bunch of numbers combined is odd or even. Now, it might seem like parity seems very simple. I mean, it's pretty easy to tell whether a number is odd or even, right? But as I hope to show you in this video, we can solve a large variety of pretty tricky problems using this idea of parity. So, to get started, let us consider some basic ideas of even and odds. So what if we look at a bunch of numbers, even numbers, and add them up? What do we get? So let's just try writing out some expressions. I'm sure everyone knows what happens, but let's just pick a bunch of even numbers and add them. Here's two even numbers, I add them, I get 12. What kind of a number is 12? If we think about its parity, it's even. If we add more even numbers together, let's say three even numbers, what do we get? Oh, we also get 12. If we just randomly pick even numbers and we add them to each other, what are we going to get? Well, we are also going to get an even number. So I bet all of you probably already know this fact, but could you explain why that is? It's a little challenging to explain why something is true when the thing that you already know is true is very obvious to you. It's actually harder to explain that than it is to explain something that isn't obvious. But let's still give it a shot. So here's an even number. Let's say the number 8, and I'm adding it to some other number. Let's say the number 6, and I'm just going to draw little rectangles here for 8 and 6. Well, what do we know about even numbers? An even number can be split exactly in half with no leftovers, right? We know that 8 is 2 times 4, so it can be divided into 2 4s. And 6 as well, because it's an even number, we could write it as 2 times 3. So we could split 6 in half. We can divide 6 by 2 and we get an answer of 3. So we could also think of splitting this number right here, this little rectangle, into 2 halves. But when we add these two numbers, well, what are we going to get? Visually, we just put two of these blue chunks of 4 together and two of these green chunks of 3 each together, and we get 14. But we know that 14 is an even number because we can see how we can easily split it in half. We simply have two blue chunks and two green chunks. So to split 14 exactly in half, all we have to do is take a blue chunk out of the total here and take a green chunk out of the total. And if we do so, what do we get? We get a blue chunk, which is 4, plus a green chunk, which is worth 3, and we get 7. And we get another blue chunk and another green chunk, which is another 4 plus 3, which is 7. And of course, 14 has been split exactly in half. We could write it as 2 7s added together. And of course, with this explanation, you can do this with any two even numbers, because each even number can be split into two chunks of equal size, and then when you add all these, you can get 4 chunks, and then you can combine 2 chunks each of the same types. You can always get an even number. So even plus even, and we're talking about whole numbers here, right? This is only true. Parity only makes sense in the context of whole numbers. So even plus even is equal to even. All right, so that was pretty easy. Can we try the same idea with odd numbers. So what happens if we add a bunch of odd numbers together? What will happen? Well, let's just give it a shot with different examples and see what happens. If I take two odd numbers, 1 plus 3, we get 4, which is an even number. Okay, so odd plus odd is equal to even. Can we summarize then? If we add a bunch of odd numbers, we always get an even number. Is it true? Well, what happens if we take 1 plus 3 plus another odd number? That is, if we take 3 odd numbers, what do we get? It's easy to see that we get 9 here, which is an odd number. So when adding odd numbers together, it appears that it matters as to how many odd numbers we're actually adding. Let's add now 4 odd numbers together. What do we get? 21 plus 9 is 30, which is an even number. So can we summarize our pattern that we found here? It appears to be the case that if you add an odd number of odd numbers added together, an odd number of odd numbers, wow, added together is equal to an odd sum or an odd total. And if we add, on the other hand, an even number of odd numbers added together is equal to an even sum. Everything else above stays the same, so I'm not going to repeat writing it here. All right, can we again I know this seems obvious, but can we sort of prove it or explain it logically with pictures? Well, let's imagine we have a little number line here. What do we know about a number line? We know that whole numbers on the number line are always 1 apart. So consecutive whole numbers are always 1 apart. 0, 1, 2, 3, 4, 5, and so on. And you can do the same thing with negative numbers, -1, -2, and so on. Now imagine we start with 2 odd numbers. Well, because notice any odd number is right in between 2 even numbers, and any even number is right in between 2 odd numbers. Basically, they alternate, they switch. If you add 1 to an even number, you get an odd. If you then add 1 again to an odd number, you get an even number. So if you move around the number line, it doesn't matter whether you add or whether you subtract, you're always switching parity. So when you add 1 or subtract 1 from a whole number, you can see from the number line visually here that we are switching the parity of the number. So that is, we're switching the parity. We're changing from even to odd to even to odd. So we're alternating every time we add or subtract 1. All right, so what that means is that if we want to add, let's say, 2 odd numbers together, we could start again visually looking at these odd numbers. And what did we say? We said that every odd number is located right next to 2 even numbers that are 1 away from it. For example, we can think of the number 7 here as 6 plus 1. And we can think of the number 9 as 8 plus 1. What happens when we add these two numbers? Well, we already know what happens when we add the 6 with the 8. Since these are both even numbers from our previous result of even plus even, we know we are going to get an even number. So 6 plus 8 is going to be an even number. What else do we have to add? We still have to add 1 plus 1. But 1 plus 1 is 2, which is an even number. So in the end, Notice we are adding an even sum, 6 plus 8, plus another even sum, 1 plus 1. And so the result from our previous work in the previous problem, we know that even plus even is going to be even. And of course, 9 plus 7 is 16. This argument that we made right here with these two example numbers, 7 plus 9, we could have made with any two odd numbers. Because any other two odd numbers, we could visually write them as some even number plus one more. We know that has to be the case from the number line. All right, so we know now that odd plus odd is equal to even. But what if we add three odd numbers together? Well, three odd numbers together would be odd plus odd plus odd. We add the first two numbers, that gives us even. And now we have to add one more odd number to our even result. Can we guess what this is going to be? From our examples, we expect that we're going to get an odd sum, right? When we add three odd numbers together. Let's visually see that that's correct. So now we have an even number, an even sum, and we're adding it to an odd number. So let's make up a visual example of this. So perhaps we have the number 8. This is an even number. We are adding it to some other odd number, so let's just make up an odd number. Here's the number 7. In fact, let's write 7 as the number 6 plus one more. We know that 7 is an odd number and it's equal to an even number, right? It's one away on the number line from an even number plus one more. So 8 plus 7 is equal to 8 plus 6, the sum of two even numbers, which we know is going to be even, plus one more. Well, what happens when we add one more to an even number? We must get an odd number. Why? Because we always switch parity when we move by up and down by one on the number line, right? So we know the result in the end has to be an odd number, and indeed, of course, this is equal to 15. That is an odd number. So that was quite a lot of explanation. Was it really necessary? Was it really necessary to think so hard about this simple idea? Well, if you've never thought about it, it's always great to find an explanation. Even though it's obvious to you, it always still tests your reasoning skills to be able to explain something very, very logically so that anybody could understand why it's true. It's not good enough to just say, well, that's just the rule. Even plus even is equal to even, and odd plus even is always equal to odd, and you can't really say anything more beyond that. It doesn't feel good unless you can really explain it. But more importantly, as we'll see in a second, if we really understand these ideas very, very well, we are going to be able to solve a wide variety of interesting problems. Problems that seem quite hard when we first look at them, but once we realize the problems really reduce down to understanding odds and evens, that is, understanding parity really well, when we realize that, we all of a sudden realize that the solution can be quite simple. All right, so moving on. So let's just summarize actually. What does this mean? If we add an odd number of odd numbers added together is an odd sum, an even number of odd numbers gives us an even sum, and an even plus an odd number we just saw with our example gives us an odd result. All right, so our summary is the following. Even plus even is even. Odd plus odd is even. And even plus odd is odd. What about odd minus odd? Do we have to do all this work again for subtraction? take a minute and think about it. See if you can find a quick explanation using what we just saw for whether an odd minus an odd equals an even or an odd. So one way to think about it is to look at this first equation right here. Notice an even plus an odd is equal to an odd. What does that mean? That means that if we subtract the odd minus the odd, so if we subtract this minus this, we'll be left with an even. So just from our previous work here, we can think of subtraction as the opposite of addition. So we can immediately notice that an odd minus an odd is equal to an even. What about an even minus an even? Hopefully, it's also obvious that we can do the same thing here. If an even plus an even is even, well, an even minus an even must be even. And finally, if an odd plus an odd is equal to even, then an even minus an odd is equal to an odd. For example, if 7 plus 9 is equal to 16, then 16 even minus 9 is equal to even minus odd is equal to odd. So there's no great mystery here. In fact, these rules are exactly the same. If you look at them and compare them, even minus odd is odd. Even plus odd is also odd. Even minus even is even, and even plus even is also even. Odd minus odd is even, and odd plus odd is also even. So what this is showing us is that you don't have to worry whether you're adding or subtracting. So any subtractions that you do, the rule, the parity of the result is going to be the same as if you were adding the numbers instead. The subtraction here will not make a difference.